Alright, so we're moving right along here. Today's objectives are to identify the IUPAC naming rules for halides.
So before we get started here, let's talk about some four important things about halides. First of all, where you can find them on the periodic table is group 17. That's fluorine, chlorine, bromine, and iodine. When you see these in organic compounds, they're always single bonded to a carbon, never doubles, never triples. They have one of the lowest priorities in naming. You'll understand more about that as we go forward. And lastly, halides are always given the ending O and are named before the alkane name. So for example, if you have bromine attached to your carbon chain, you drop the ene ending and add an O instead. So this would be called bromo.
Alright, let's take a look at the naming rules for halides. A lot of the rules are the same as naming branch chains. The first one is to find the largest carbon chain, number the chain starting with the end closest to the attached group, name the alkane. Identify and name attached groups and assign the proper number to any group. Halides get the O ending, so iodo, chloro, fluoro, bromo. And then lastly, to assemble the name. Substituents in alphabetical order, not numerical order. Remember that.
So let's try to apply these 5 rules to our first example molecule here. Notice we have a halogen chlorine down the bottom. First thing you do is same as always, find the largest carbon chain. There it is. Next thing you want to do is number that chain starting at the end closest to the attached groups. In this case we have a methyl closer to the left hand side, so we're going to start there. So that's carbon 1, 2, 3, 4, and 5 all the way across. Next thing is to name that alkane, the parent chain. 5 carbons makes this a pent, and since they're all single bonds in between there, we're going to call this a pentane. Fourth rule: identify the attached groups, name the attached groups, and number the attached groups. First of all, let's deal with the halogen. That's a chlorine, but again we drop the ene and add O, so this is a 3-chloro because it's coming off of carbon 3. We also have a methyl group here, the CH3, coming off of carbon 2, so that's a 2-methyl. Final rule, as always, is assemble the name. Attach groups out front, chloro first, methyl second, alphabetized in the backbone. Pentane always comes last.
Alright, so we're going to keep moving on here. This one we have a doozy of one. We have one with 5 halides attached to the carbon group. So let's work through it by going through the rules. The first one is to find the largest chain. There it is. Number the chain starting at the end closest to the attached group. Here we have something different because here we have 2 attached to this carbon. This one we have 3 halides attached to the carbon. So because they both have halides attached, we're going to go with the one that has more attached groups coming off of it. So we're going to number 1, 2. We're going to name the alkane. It's an ethane. Eth is our prefix, A and E, because there's no double bonds in between the 2 carbons. Next we're going to identify and name the attached groups and assign the proper number. So we have 3 bromos. So we have a 1,2,2 tribromo, and we have a 1,1 difluoro. Notice that the bromo goes before the fluoro because the prefixes are not in consideration when we name these. So we have a 1,2,2 tribromo 1,1 difluoroethane.
Okay, so here comes the tough part. We have to deal with some reactions that these halogens undergo. This first one is called a halogenation. This is a type of addition reaction where the double bond is displaced, and it allows for 1 or more halogens to bond to either side of wherever the double bond was located. On the left we have an example of a single halogenation. Notice the hydrocarbon has a double bond. It has to for this reaction to take place. It's also going to react with hydrogen attached to any halogen. Really will work for this. In this case it's HBr. So what happens is the H and the Br separate from each other. They become 2 separate atoms. The hydrogen is going to attach to the carbon on the right side of the double bond. The bromine is going to attach to the carbon on the left side of the double bond. And the double bond also has to break and turn into a single bond for this to happen. Here's your product molecule. Notice the Br is now attached here. The hydrogen is now attached here. Out of that H2, one of those hydrogens came from this original molecule, and that's your final product. You can also have what's known as a double halogenation, where the same thing happens, except notice now we're reacting with 2 halogens, the Br2. They separate from each other. One attaches here, one attaches here, and this time your product involves both bromines attached in a single bond in between the two carbons which used to have a double bond.
Our second halide reaction is an elimination reaction, where a bromo gets displaced, or the halogen gets displaced, and a hydrogen as well gets displaced to create a double bond or a triple bond. If we take a look from alkane to alkene, one of these bromos is going to pop off, that bond is going to come in, and a hydrogen is going to go into solution to get your end product looking like this. On the other side, we have an alkene to an alkyne. Same thing's going to happen. Bromo is going to pop off, the bond's going to fold in to make a triple bond, and the other hydrogen is going to pop off. Otherwise, this carbon would have too many bonds to it. So that will give us our triple bond alkene to alkyne.
Alright everyone, so that pretty much wraps it up for today. Let's recap some of the things you saw. First of all, we identified the IUPAC naming rules for naming halides, and you saw several examples of how to do that with bromos, chloros, and iodos. We also saw some of the reactions that these halogens undergo. Please bring your questions to class.